Hi there, I'm Dr. Koenig, and this is a video tutorial on solving equations with variables on both sides of that equal sign. Let's jump in. Now, when I say we're solving equations with variables on both sides, this is what that looks like. So you'll see my equal sign, I've got a 2x on the left side and a negative 9x on the right-hand side. That's what makes it a different kind of equation than I've covered in videos previously. Now, these equations are essentially the same as any other equation. We're still really trying to isolate x. The problem is we've got x's on both sides that we have to contend with first. But once we deal with those, it really looks like any other equation. So if you've seen my prior videos, I tend to put a line down the equal sign. That kind of helps me remember that I'm looking either on the left-hand side for like terms or on the right-hand side for like terms, but certainly not in both locations. It also helps me to remember that whatever I'm doing on one side, I have to do on the other. So if I'm adding something to one side, I need to add to the other side as well to keep the balance. So here I've got two variables, and in order to get them together, some people are really tempted to combine them like terms. So they would be tempted to add 2x negative 9x, but because they're on opposite sides, we can't do that. Instead, we're going to use an opposite operation to move one of them away from its side to the other side. For example, because I've got a negative 9x, I'm going to add 9x to both sides. On the left-hand side, you'll notice that I'm not going to add it to the 4x. That's because those are not like terms. Those are different terms. I'm going to write my plus 9x. This time I'm going to focus it under the 2x. Those are the those are the ones I'm adding. Now, the reason I've done that is because on the right-hand side, negative 9x plus 9x gives me 0 x's. So I have no x's left on the right-hand side. All I have left is that minus 7 or negative 7. On the left-hand side, I can now add 2x and 9x, and I get 11x. I'll bring down my plus 4, and here's where I stand. This is a two-step equation. This is a much simpler equation. Once I have moved one variable from its side to the other side, looking specifically to get 0 x's, like I did here, now I've got a two-step equation that's much easier to solve. From here, I can really focus on that variable I'm trying to isolate. So I see that there's a plus 4. I need to subtract 4 on both sides. On the left-hand side, 4 minus 4 is 0, so I'm left with just 11x. On the right-hand side, I have negative 7 minus 4, or negative 7 plus negative 4. Either way, you get to negative 11. And then in order to get to 1x, which is what I'm searching for, I'm going to divide by 11 on both sides. That gives me 1x, and that tells me that 1x is equal to negative 1. Here's another example. The only difference here is that I threw in some rational numbers, so you'll see some decimals. My process for solving is going to be the same. So first, I'll draw a line down the equal sign. Again, I'm trying to get those variables both to one side, and I do that using an opposite operation. So I have a positive 3x and a positive 18x, so I'll be subtracting one of them. It doesn't actually matter which one I start with, but I'm going to choose the 3x. I'm going to subtract the 3x from both sides because that will leave me with a nice positive number. If I had instead subtracted 18x, I'd get to a negative number. And sometimes negatives are fodder for mistakes and things get lost along the way. So anytime we can stick with positives, that tends to be a good thing in my opinion. Anyhow, on the left-hand side, I have subtracted 3x from 3x, leaving me with no x's. I'll bring down my minus 6.5, which now I'm going to consider a negative 6.5. On the right-hand side, I'm left with 15x, positive 15x, minus 15.5. Again, I want to isolate that variable, so I tend to think it's helpful to circle it, and that kind of points me toward the right side of the equation and lets me know that I need to add 15.5 to both sides. Now, negative 6.5 plus 15.5 would be the same as taking 15.5 and subtracting 6.5, which gets me to 9. On the right-hand side, I still have 15x, and I need not 15x, but 1x. So I'm going to divide by 15 on both sides, and I get 9/15. Now, the answer 9/15 is perfectly fine, except that it can simplify. So this is a great example with multiple types of rational numbers. We had decimals, and now we've got a fraction. Now, we could do long division for 9/15, and that would be an appropriate way to solve. However, I kind of like to leave it as a fraction and simplify. In this case, I can divide both of those numbers by 3, which gives me x equal to 3/5. Now I only have one more example for you today, and that's because these are kind of longer examples. I wanted to show you this one because we start out with a fraction and we also start out with some like terms. So I'm going to focus my attention on the left-hand side. I've got 3 terms there, and that tells me that 2 of them are likely like terms. I'm noticing that I have a -4 and a -28, and those are 2 things that can be combined. So when I do that, I end up with 2x, and I'm adding these 2 terms together like it's a -28, or you can think of it as -4 minus 28. Either way, you get to a -32. So I've got 2x minus 32. And then I'm going to bring down the rest of the equation before I draw that line down the equal sign, just so I don't run out of room today. Now again, I want to move one of my variables by using an opposite operation. Both of them are positive, so I know that I'll be subtracting one of them. You could really go either way. I do want to show you that if you subtract 2x, a smaller number like 2/3 minus a bigger number like 2 is going to give you a negative. That's what I was trying to avoid in the last equation. So on this one, instead of subtracting that 2x, I'm going to subtract the 2/3 from both sides. So minus 2/3 x minus 2/3 x. On the right-hand side, 2/3 minus 2/3 is going to end up with a 0/3, 0 x's. So I'll just bring down that minus 4. It is now a -4. On the left-hand side, I really need to figure out what 2 minus 2/3 is. So let's come off to the side. In order to subtract those, think back to your fraction rules. I can put 2 over 1 to make it a fraction, but they do need common denominators before we can subtract. So I'm going to multiply both of those, that 2 and that 1, by 3, giving me 6/3. It's equivalent to 2 over 1. It's equivalent to 2, the whole number. But now I've got like terms, or I've got common denominators, so I can subtract. 6/3 minus 2/3 gives me 4/3 x. So although this is a doozy, we've taken many more steps. We've now gotten our equation into a form that we're more familiar with. It's now a 2-step equation, which is much easier to solve. I want to figure out where my variable is because that's what I'm trying to isolate. And that tells me that I need to add 32 to both sides. That leaves me on the left-hand side with 0 in my constants. So I've got 4/3 x only on the left-hand side. On the right-hand side, -4 plus 32 is the same as 32 minus 4, which I know is 28. Now I'm left with that fraction. So 4/3 is being multiplied by x. The opposite operation, as we know, would be to divide that 4/3 on both sides. Now, when we divide a fraction, we always end up multiplying by the reciprocal. So I kind of find it a little bit easier to actually just go straight to the multiplying by the reciprocal piece. So I'm going to write times 3/4 on both sides. Now here's why that works. On the left-hand side, 3 times 4 is 12, 4 times 3 is 12, so I end up with 12 over 12x, which is the same as 1x. So I've got x equal to something. Now on the right-hand side, I need to do 28 times 3/4. So I'm going to come off to the side again. I'm going to do 28 over 1 times 3 over 4. Now we know that we could multiply straight across 28 times 3, 1 times 4, but that 28 times 3 is going to be a large number for sure. We're probably going to have to simplify something. A way to simplify this process is to do what's called cross-canceling. So I can look at the cross products, the 28 and the 4, and I can see if there's anything that they can simplify by together. I could do the same thing for the 1 and the 3, except that because the 1 is a 1, there's no simplifying a 1. It's as low as it's going to get. Now, with the 28 and the 4, they can both divide by 4. 4 divided by 4 is 1. 28 divided by 4 is 7. And now I've got much easier numbers to multiply. 7 times 3 gives me 21. 1 times 1 is 1. So my answer is 21 over 1, which is positive 21. So these equations are pretty complicated. There are variables everywhere. You might be combining like terms. You might have rational numbers. But here are kind of the nuts and bolts of solving an equation that has variables on both sides. Your idea is to get 0 x's, or 0 variables on one of the sides, and you do that using opposite operations. Now, once you've done that and you've gotten your variables all to one side and collected them together, you're left with either a one-step or two-step equation that's a little simpler, a little more approachable than what we started with. So you have simplified the problem that you're solving. I hope this video gave you some thoughts on how to begin solving these equations that have variables kind of all over the place. I'm so glad you were here. Thanks for being here, and I'll see you next time.